morning. Thank you for coming here to listen my talk. First, I'm going to introduce myself. I'm Juan Lopez, and I'm working as tech lead in ThoughtWorks Spain. This is my humble way to give back to the community all the knowledge it has given to me before. And the topic is continuous deployment in machine learning systems. Why? Because I think the last years we have evolved a lot machine learning, and I think this is a good moment for stopping and think about, okay, what is the best way to do continuous deployment here, and which are the best practices to do it. The goal is understand how can we achieve this continuous deployment. At the end, at the beginning, I'm going to talk a little bit about the context, about what is continuous deployment and what is machine learning. After that, I'm going to talk about the machine learning systems and the different pipelines. At the end, we are going to see some stuff to monitoring and some conclusions. Okay, continuous deployment. What is continuous deployment? Continuous deployment is a software strategy to put automatically the new commits we do in code. At the end, we want to reduce the gap between a new idea and when this idea is in production. Why everybody wants it? Because we can have new features on the fly, we can have new features every day, because the quality of the software goes up, because we are doing smaller changes, and because of these smaller changes, we have a faster development, because it's easier to test the new features. And we have more experimentation and more innovation, because we have a new feature today, and we put this new feature the next month. This is not innovation. Innovation is today, because we are living in a fast world. In a nutshell, we want to reduce the gap between a new idea and when this idea is in production. We have what is continuous deployment, but the topic is continuous deployment in machine learning systems. So we need to talk about what is machine learning. First of all, machine learning is not only a hype. I know every day you are listening news about machine learning in the newspapers and the TV, in your smartphone, but this is not only a hype. We can see machine learning every day and everywhere, in your smartphone, in the TV, and machine learning is something very useful. But what is machine learning? Okay, first, machine learning is not the same like artificial intelligence. Machine learning is only a subset of artificial intelligence. We use data for training our models. After that, our models can predict new data. So that's it, machine learning. And machine learning are statistical models that systems use to perform a specific task. And the main difference between machine learning and the traditional algorithm is that in machine learning doesn't use explicit extraction, relying on patterns and inference instead, okay? And maybe you are thinking now, okay, we understand machine learning, but why we want continuous deployment in machine learning? Okay, I think for the same reason that before, because we want to reduce the gap between a new idea in machine learning and when this idea is in production. Okay, continuous deployment in machine learning is cool, but how do we achieve continuous deployment? I asked myself some years ago this question, and I really thought that it was impossible. I remember I started to work in a pet project. I really thought it's impossible because I couldn't be able to understand which kind of tests we need to do continuous deployment. And I remember in 2017, some people from Google put this paper, and I remember this day because I read it. Really, it's not a paper about continuous deployment, but it's a paper about which kind of test we need in machine learning. And in the first slide of this paper, I remember two pictures. The first one is this one. We have here a traditional system with the different parts, the code, the production environment, and different tests we need. And the second picture was this one. First, you can see it's more complex machine learning system. Why is more complex? Because we have two new parts, the model part and the data part, okay? And the different tests we need to do here. Okay, so far the introduction, the context about what is continuous deployment in machine learning, and now we are going to talk about machine learning systems. This is a simple schema about the different parts we need to explain in this kind of systems. The first one is the code part. I'm going to start with code part because I think everybody here understand this part because it's the same like in traditional systems. Here always code is always code, so you need to apply always the best practice when you are coding. And why in machine learning systems too? Because we have not only the models, the data, and this fancy stuff. We have also different service, APIs, and other things. So we need to code a lot, to code in a lot. We need to apply string programming practices like TDD, pair programming, always when we are coding. Quality gates, I think everybody here understand what is a Sonar and other tools, because if our code is not good, we want to stop this pipeline. Feature toggles, because we want to do production-ready code, so we need to put some feature code, some feature toggles. And finally, I put here the test pyramid. This picture is from ThoughtWorks Insight blog. This pyramid basically said that we need to do more automatic tests and less manual testing. Okay. And this is only an example of a code pipeline. Depends on your project, maybe you have more steps or less steps. But here you can see the different parts, continuous integration, continuous delivery, and continuous deployment. Basically, it depends on your project, because everybody wants to achieve continuous deployment, but sometimes we can't do it. The main difference between continuous delivery and continuous deployment is in continuous deployment, we put directly our new features in production. Before to talk about data, I want to read a quote from the paper before. Unlike in traditional software systems, the behavior of machine learning systems is not specified directly in code, but is learning from data. Okay, why is important this quote? Because in traditional systems, we can ensure the quality of our code only with code, with our tests. But here, our test depends on the sets of data for training models. So this is so important. And if data is important, we're going to talk about data. Okay, this is only an example of a data pipeline. First, I just wanted to say that now the mindset is changing. We're working in a DDD mindset. So maybe we need a data pipeline for each domain. So this is important. I'm going to explain this data pipeline step by step. The first step is the ingestion of the data. We live in a big data world, so we have a lot of sources of data. We need to get all this data with our system, with it. We are going to get this data from the different sources, like the cloud, the files, the databases, the real-time streams, and put in a data lake. A data lake is basically where you are going to put the raw data. And this is so important. You need to understand your source, because the data is the most important part in your system. So you need data catalogs for understand your source. And maybe you need to put here the owner of the source. You need an schema, because you need to understand your data and know your data. You need to governance your data. This is so important. For instance, if you have a source with the people age, you need to understand that this data is an integer number between 1 and, 150. This is so important. You need to know your data. This is important because, okay, you need to monitoring the silent failures, because maybe one of your source stop producing new data, and this is so important because maybe your model depends on this data. So you need to monitor it. The next step is the data wrangling or data mangling. Basically, now we have the data in a raw state, but we need this data in a production-ready state. So we need to transform this data and put in a data mart, not data warehouse, because we are in a DDD mindset, and a data warehouse is for the whole company, and we want a data mart for each domain. This is important. Okay, if you are doing transformations, maybe you are doing some code. So I repeat again, code is always code. So you need to apply all the best practices here too. Because if your data is bad, everything is bad, okay, in your systems. And maybe this is the step when you are going to do some data cleaning, but depends on your project. You need to decide what do you want to do with this strange data. The next step is like sub-pipeline inside the data pipeline. And here, basically, we need to cut our data because we live in a big data world and we have tons of data. Basically, in our computers, we cannot work with these tons of data. So we need to cut this data. Maybe you are thinking that if you cut the whole data, maybe your models fail in production, but after this part, I'm going to talk about models and I'm going to explain it. So we need to cut our data because we love our data scientists and we want to make their life easier. So we're going to cut this data, but it's important. We cannot cut this data in some way. We need to do in a statistical way because maybe this is a stupid example, but if you want to do a summary of a book and this book has, I don't know, 100 chapters, you can cut from the chapter 1 to the chapter 5 because maybe there is some important information in the chapter 15, I don't know. Okay, data security. This is a super important thing because we need to take care of our clients, so we need to take care of their data. So maybe we need to anonymize some sensitive data because we cannot work with sensitive data in our computers and in our testing environment. So it's super important. Versioning data. Why versioning data? Because I'm sure your model are going to fail in production because shit happens, you know. So when it happens, you are going to, you want to have the same data in your testing environments. So you need to have snapshots of the data. This is the versioning data. And finally, training serving SKU. What is this? Basically, if you train your model with stale data, probably your model are going to have strange behaviors in production. So you need to reduce the gap or this gap. And before starting with the models part, I just wanted to read 3 quotes. The first one is a common quote in statistics, maybe from centuries ago. It said, all models are wrong. But in 1978, an important mathematician named George Box expanded this quote and said, all models are wrong, but some are useful. And this is true because we are using a lot of models and really they are super useful. And finally, 2 weeks ago, in the TensorFlow's blog, I read this quote, all models are wrong, some are useful for a short period of time. So they are expanding this quote, and I think this is so important because time is very important in machine learning systems. Okay, so models part. Okay, before starting with the models pipeline, I want to say some important keys. The first one is you need to design and evaluate the reward function, and this is not only a task for the data scientists or for the engineers, this is a task for the whole company because our model is super important and we need to define very well this function. And you need to define the reward function and you need to define what is an error and what is a failure in your model because maybe if you are predicting prices, if you have a €1 price, maybe you think, depends on if you are predicting the prices of a pencil, maybe this is good, but if you are predicting the prices of the houses, this is a failure. So you need to define the failures in your system. I said before that your model are going to fail in production because it happens. So maybe not errors, but maybe your model has not enough data. So you need to, basically, this is the perfect moment to put here a mechanism for user feedback, okay? You need to try to tie the model changes to a clear metric from the user point of view, because finally we want to use this model for our clients, okay? I understand that we need many metrics to understand if our model is running properly, but we need to define only one objective, okay, for understanding if our model is running properly, okay? Super important, and now we are going to talk about it. So this is a sample of a models pipeline. Before starting explaining it, I just wanted to say that probably today your data scientists are using TensorFlow or Keras or other framework, but maybe the next month they are going to want to change this framework. So you need to think about it before defining this pipeline. Okay, the first step is the coding of the new model. Basically, if you are doing code is always code, so you need to apply always the best practices here. And the first step in this pipeline is when the pipeline run all the tests in your code. So here is the same like in traditional systems. And finally, when the tests are passing, you have a new version of the model. The next step is the more complex step, is the training step. Here you have 3 different parts. The first one is the feature engineering. Basically here is where your system are going to decide which features are going to use in the training step. Here maybe is where you want to put some algorithms for fixing some problems in the data, like unbalancing data, unknown unknowns, and so on. You need to be critical with your features because basically data dependencies cost more than code dependencies. So you need to be careful here because basically this is a trade-off between put all the features here, the infrastructure you use because it has a lot of dependencies. The next step is the training. Here only record that training service queue is so important. You need to reduce the gap between the training and the deployment of the model. I know this is difficult, but if you can, it's better if your model has deterministic behavior because it simplifies a lot the testing of the models. And the last step is the auto-tune of the hyperparameters. There are some algorithms for doing it, but basically these algorithms run this loop several times, choose the best hyperparameters we have in our model. Okay, the next step, I named it the models competition. And basically here we have the new model, for instance, the model 1, okay, the model in production and the other models we have in our system, okay, the past models. Basically here we are going to pass production data to all models, to every model, for understanding which are the best model, which model we want to put in production. We are going to pass this data in a shadow traffic way, so only the model in pro is returning data to the production system. We need to decide which are the best model and we are going to do in terms of the performance. So we are going to test the models with production data. And basically we are going to check the reward function and the failures, and with this result we are going to decide which are the best model, which is the best model. But be careful because maybe you have super cool model, but maybe the quality, the accuracy in the model is good, but maybe in a data slice you have a poor quality, so you need to realize about it and have a baseline of accuracy. For instance, if you have a model that predicts something in the whole world, maybe you have a bad prediction in one country. So what do you want to do in this case? Maybe you need a baseline of accuracy and decide that this model is not good in production. And finally, you need to apply the feedback loop in your model because this is a very important thing in your model. The model needs to learn with new data. And okay, we have our champion. Imagine that this is the best model, the super fancy and cool model. Okay, we want to put in production, but we cannot put ARM running out because this is so dangerous. We need to put this model in a shadow traffic way for understanding how the model is running with real data. Because we trained our model with past data, always. It's impossible to train with future data, obviously. So in this way, we're going to understand, seeing the logs, if our model is running properly in production. There are more techniques for put in production the models. There are like canary releases, A/B test, and finally, you need to define a rollback because you need to define a protocol, okay? Because if your model is failing in production, you need to do a rollback, okay? So you need to define this rollback. Okay, so far the monitoring machine learning system, the different pipelines, but now we're going to talk about observability, about monitoring, because I said before, shit happens. Monitoring is important in continuous deployment because Okay, we are doing fast deployments, but we need to understand if our system, if our service, if our code, if our models is running properly. And the first thing here, we are doing complex systems, so we need a dashboard with clear and useful data only. This is so important because if we have a dashboard with all the data, it's impossible to understand if our system is running properly. The second point is you need to monitoring schema, because I said before that you need to understand your data and you need to understand if your data is changing, so you need to monitoring it. Obviously, we have a very complex infrastructure and we need to monitoring it, like RAM, training speed, and other stuff. Because if something is running infrastructure, maybe your model is not running properly. What's more, you need to monitoring the user feedback if you have an error here. Stale models. We live in a fast world and the data is changing every day. So you need to understand if our data has changed. There are some algorithms, statistical algorithms, for understand it, but basically you need to understand if the distribution of your data has changed. So this is a simple graph, but you can see here your data has changed. Okay. What's more, a feedback loop and errors in your code, in your models, in your API, in everything, because it happens, remember? So you need to monitoring everything. And silent failures. I said before, if one of your sources stop producing new data, you need to realize about it. This is so important. And now some conclusions. First one, code is always code, so you need to apply always the best practices here. This is so important. You need to apply the stream programming techniques like TDD, pair programming, and so on, also in your models. Second point is you need to have an objective driven modeling way for doing new models. You have to try the model to the user experience. Know your data, because the data is the most important thing in our systems, so we need to understand our data. If we have stale data, if we have schema changes or so on. Finally, we are doing very complex systems, so we need to have clear metrics and a dashboard with only useful information. And that's it. Thank you everybody for coming here, and if you have some questions.